Yes guys, welcome back to Pure Math School. We're still continuing with our seventh part of the introductory work, that's solutions of triangle. And today, in our previous video, we talked about the cosine rule. And today we are going to look at the sine rule. For the case of the sine rule, let's consider this triangle. Okay, we have that triangle. We can name these vertices A, B and C. Then that means here we have angle B, here we have angle A, here we have angle C. Then let's say the sides opposite to the angles in lowercase, like this, opposite to this C is that lowercase c, opposite that angle B is lowercase b, and that A is a lowercase a. So the sine rule is given by this, that the length of the side out of the sine of the sine of the angle opposite to that side is equal to the length of another side over the sine of the angle of opposite to that side as well, and equal to the length of this over the sine of that angle as well, which we can write in simple term as this: b out of sine b equals to c out of sine c. You need to know that this lowercase c, you have to know that this is the ones up here are the length of the sides, that then A, B, C, this one is in uppercase, are the angles. So let us continue. We can see that here, I think that all we need to do about this, we are going to prove. We're going to get the proof of the cosine rule. We're going to derive the cosine rule or show that it's like this. Let's get the proof here. So in this triangle, we can see we can drop a perpendicular onto AC from that B. So we can draw one which has a perpendicular dropped already. This was A, B, C. This was angle C. This was angle A. This was angle B. This was side A, side C, and side B. Let's drop a perpendicular from there onto this line, meeting there at 90 degrees. Then we can name there to be N. Okay, then let's try to see that. Let's give H to be the height of that perpendicular distance. So we don't we don't know that H, that means we can get that H. So let's consider from triangle ABN, that first one, ABN, we can get sine. Since in that formula we have, in this formula of the sine rule, we have only sines, we see that we are getting only the sine of these angles here. I think sine A, sine B, sine C. So we can just start by getting sine A here. So we say sine A is given by, remember from our SOHCAHTOA, sine is given by opposite out of hypotenuse. So we have here opposite, which is H, opposite to that angle is that side, out of hypotenuse, which is C. So what does it mean? Our H is given by C sine A. We can give that equation 1. Then from this other triangle, that BNC, triangle BNC, that sine C, we can get sine C. It's going to be given by the opposite side opposite to that, this angle C is that H, which is H, out of the hypotenuse, which is that A. Okay, that implies our H equals to A sine C. Equation 2. As you can see, equation 1 and 2 are equal. Since this h equals to that and also h equals to this, that means actually these two, C sine A and A sine C, are equal. So we are going to say that 1 equals to 2. Equations 1 and 2 are equal. So we can say that it implies that C sine A is given by A sine C. So let's divide by sine A throughout to make A this side, also divide by sine C. If you first divide by sine A here, sine A, we see is going to cancel from here, and we will remember that C equals to A sine C out of sine A. Then we again divide by sine C, then that will go, then we remain with C out of sine C. So you see that it will remain A out of sine A equals to C out of sine C. So A out of sine A equals to C out of sine C. Let me write here. We have something like that. Let us write here behind here. We realize that here we remain with A out of sine A equals to C out of sine C. Let me write it this other side so that you can get it clearly. We are remaining with A out of sine A equals to C out of sine C. Sorry, this C is in lowercase. So we have something like that. But now from this case, you remember we dropped a perpendicular from B. So that means if we drop perpendicular from one of these, we can prove similarly. We can find that A out of sine A equals to B out of sine B. Here, by this, we drop a perpendicular from, let me say, C. Let's now assume that our C is there. Then perpendicular is from C. Still there we have our angle A here, we have our angle B here. Then this side A, that side B, and this side C. And this is still our H, okay? Now we get our sine B from the same concept, from the same way we looked at before. Our sine A, we will find that it's going to be H out of B. That would imply our H equals to B sine A, okay? Then our sine B would be H out of A. That would imply our H equals to A sine B. So now H is that, H is also this. That means these two are also equal. B sine A is going to be given by A sine B. And if we divide throughout by sine A first, and also again divide throughout by sine B, we'll come out with A out of sine A equals to B out of sine B. You see that now if A equals to sine C, A out of sine A equals to C out of sine C, and also A out of sine A equals to B out of sine B, that means actually you can, since A out of sine A equals to B out of sine B, you can write just B, extend behind here and say that B out of sine B equals to that, and this also equal to that. So therefore sine rule is A out of sine A, which is equal to B out of sine B equals to C out of sine C. That's a sine rule. Let us check for another case here. There are two cases. Remember, in our cosine rule we looked at two cases. One case was when we had we created this perpendicular inside, and there is one when another case when this perpendicular can't be created inside, but you just have to try to create it outside. Let me draw for you that case. Let me say case 2. Okay, There are cases when we have something like this, then we just produce a perpendicular there. There's no way we could drop a perpendicular here. Since this one is slanting, it's very hard for you to drop a perpendicular on that line. So you just produce it and you drop it outside. So we can put here A, B, and C. Okay, then we put here maybe D. Okay, then this one we put it okay, now let's put A, B, C here, since we want to relate A, B, and C. Then we put D, the one we have just created here, which is the point of the perpendicular. Okay, so this one we put side C, that one we put side B here, then side A here. Remember this angle A, this angle B, and this angle C. Then here we give our height, the height of the perpendicular we have formed, we give it to be H. So we start from sine A. Okay, so from this triangle you pick with a perpendicular, because you only get sine, or even you use Pythagoras theory using a right angle triangle. So that's why we form that triangle, that perpendicular there. So from triangle ABD up to here, our sine A is going to be given by opposite, which is that side is opposite to A, so opposite is H, out of the hypotenuse, which is C, implying that our H is given by C sine A, equation 1. Then from this triangle CBD, what do we have? This, if this angle is C, remember from the straight line is 180 degrees, so that all of that angle is 180. But now we are removing C, that means it's 180 minus C here, this angle. Okay, because you can't, that's obtuse, that this is beyond 180 degrees, beyond 90 degrees. That means it lies in the second quadrant, which is obtuse. If you remember this, acute, obtuse, reflex. I covered that in some previous, in my I think 3 videos. The third video, if you go backwards. So we are going to have that, for us to get sine of that angle, sine of 180 degrees minus C. Okay, we can't use this because there's no way we can relate this angle with this. It's outside, so we can't use it. We are going to use this acute one, which is less than 90 degrees. So we're going to have sine of 180 minus C. This angle is going to be opposite. It's the side opposite to that angle is that which is H, out of the hypotenuse, which is that which is A. Okay, that implies actually our H is given by A sine 180 degrees minus C. But since it's 180 degrees minus C, that means it's something of this nature, whereby it's measuring C up to the second quadrant, which is obtuse. Then this is our 180 degrees. And remember minus C, I mean our 180 degrees minus C. Remember our relationship when you look at trig ratios of obtuse angle, the sine of this C is the same as the sine of 180 minus C. From our note, we noted that trig ratio of an obtuse angle is given by the same trig ratio of the supplementary angle. Supplementary angle angles add up to 180, so the supplement of C is going to be 180 minus C. So that, but with appropriate sign. Remember all, then sine here, then tan here, then cos here. Here all the trig ratios, sine, cos, and tan are positive. Here only sine is positive. Here only tan is positive. Here only cos is positive. So here, so it's with their respect, their correct signs. So here sine is positive. So our sine C is the same as sine 180 minus C. That means we can replace this one with actually with sine C. So what does it mean? H equals to A sine C. Equation 2, they are equal. H. That means C sine A and A sine C are equal. So it implies that C sine A equals to A sine C. Okay. That's what we have. So if you divide throughout by sine A, like what we did be in the video before, and divide throughout by sine C, you're going to come out with something like this, which implies A out of sine A equals to C out of sine C. And now we're going to use the same case that we looked at before. Now this time we make a perpendicular maybe to B on C, so that we can get maybe A. If you draw make a perpendicular to extend from C, like I'm going to draw this side. Let us say that similarly, let's show that A out of sine A is also equal to B out of sine B. So that means I think C will have to die. That means we will have to draw something of that nature. Then we drop here that to be 90. Okay. Then we write here, we make here B A, C up there, then B here, then we make here D. So that here is angle B, here is angle A, here is angle C. This side is C now, opposite to that. This side is going to be B, opposite to that angle. Then that side is going to be A. Then this is H, the height of the perpendicular we just dropped. So same case we're going to say that sine A is going to be given by opposite, which is H. That's from this triangle ACD. Sine A is going to be H out of B. What does it mean? H equals to B sine A. Equation 1. Then from this BCD, triangle BCD, we're going to have that is 180 minus B. The whole of this straight line is 180. Now we'll subtract that B. It's going to be 180 minus B. So that means we are going to have sine of 180 minus B. Okay. It's going to be given by opposite is H out of hypotenuse, which is A. So that H equals to A sine of 180 degrees minus B. And from our explanation that we looked at before, we're going to have B going inside there, and we have here 180 minus B. We realize that sine B equals to sine of 180 minus B, since sine is the only positive trig ratio here. Sine of the supplement of an obtuse angle is the same as that the positive sine of the supplementary angle. So that implies actually we have H giving us A sine B. Okay. So that's equation 2. So what would happen? That means H is here. H is equal to this. H is equal to that. That means B sine A is actually equal to A sine B. Oh. So B sine A equals to A sine B. Okay. So when you divide throughout by sine A and again divide throughout by sine B, you will come out with something like this again. Remember, initially we had proven that A out of sine A equals to C out of sine C. A out of sine A was also equal to C out of sine C. Okay, which implies actually that A out of sine A equals to B out of sine B equals to C out of sine C. Hence, sine rule. Okay, I think we have now proven our sine rule for both cases. So now we can check on some examples that can help us apply. And let me give you some conclusion about the sine rule. You need to observe this. Let's start from the first triangle that we looked at. Start from the first triangle we looked at here. No, this is not the first. This was case 2. Let's check on the first case that we looked at. The first case we looked at was this. if you observe this, you find this the angle opposite the side opposite is actually the length of the side opposite the sine of the angle. I mean length of this side out of sine of the angle opposite that length is going to be equal to the length of another side out of sine of the angle opposite that side, which is the same as the length of another side out of the sine of the angle opposite that side. That's very important for you. You need to know how to determine that in your sine rule, and so that you can know how to apply when they give you examples concerning sine rule. So let's continue to some few examples that you might need to look at as far as the sine rule is concerned. Let's check examples. First example, find the length of the side BC in the given. Okay, let's say this is B, C, and this is A, and let me say this angle is 55 degrees. Okay, then here let me say this is 72 degrees, and they've given this length to be 8.3 centimeters. Okay, they want you to find this side BC. So we first say that using sine rule, we observe that we have a length and the angle. Okay, so we have, so it's length out of sine of the angle opposite to that length, so it's 8.3 out of sine 72 degrees being given by length of another side out of the sine of the angle opposite that side, which is BC out of sine of 55 degrees. From there we can now solve for B. We have it's the only unknown we have, so our BC will be, if we multiply throughout by this to remove sine 55 and also by sine 55, that will go. So you have BC equals to 8.3 sine 55 out of sine 72 degrees. So let's check in our calculator here. Okay, we have there we have 8.3 times sine 55, 8.3 times sine 55. It's going to give us that, then divided by sine 72, divide by sine 72. Okay, we have 7.14 or 45, we can 48, we can round off to 2 decimal places, so BC, it can be 7.15 centimeters to 2 decimal places. That's it. So we check on another example, still to do with the sine rule. Find x in the given triangle below. Find x. It's an angle, I think angle x. So the triangle is like this, and let's put our x there. Let us put an angle 70 there, 8 centimeters, then 6 centimeters here. Okay. Now we can still use our sine rule here. We have an angle and a side already given, another angle and side opposite it given also. So from sine rule, it's going to be length of this length, which is this 8 out of sine of the angle opposite to that length, to that side, that's sine 70, being given by another length, which is 6 out of sine of the angle opposite that length, sine x. Okay, So we have here sine x giving us, if we multiply throughout by sine x will come up here by sine x to remove it from there. Okay, then we remain with this. Then to remove this, we multiply throughout by sine 70. So there we're going to remain it's 6 sine 70. Then divide by 8 to remove from this side of sine x. Okay, that means our x is actually going to be arc sine of the whole of that. I think 6 sine, let's check our calculator. Okay, we have 6 times sine 70. That is 5.638. Then divide by 8, which is 0.70476. We round to 4 decimal places, 0.7048. Okay, so that means that angle x is going to be arc sine of that. I told you to get arc sine of the answer. We're going to press shift, since shift has the same color, this color here with the one, are you seeing arc sine here having the same color? So for you to get that arc sine, you have to press that shift first, then that arc sine. So it's going to shift of sine of 0.7048. We have 44.8 degrees. Okay, but now when you get the angles, you need to remember that some angles, for some cases, you need to consider both cases. For the case of the angle to be obtuse and acute, we already found the acute. So how about we check for the obtuse? You already looked, we have got an acute angle already, but we need, it's good to always check, because remember that it's a sine of an acute angle. We have already seen it's sine of an acute angle. 44 is an acute angle, which may also be the same as sine of 180 minus x. Okay, since we have this in our this relationship is there for obtuse angles. So what if x is obtuse? What would we do? So we check, though in case we will prove whether it's okay. Remember, all the angles here must add up to 180 degrees. Okay, so we check for the case of what if now it's, we have since sine x the same as sine of 180 minus x. Okay, that's okay, that's true. And now our x is that means sine of that will be, that means actually we're going to have something like sine of x being equal to sine of that minus 44. So that means we are going to actually have sine of 180 minus 44.8 degrees, giving us, that's from here, I mean, let's put x because we didn't know it yet. We want to get the real angle there. We are looking for another x. So we have this was also equal to sine of 180 minus x. So we now take, we have taken this side, we now take also this side. Okay, it's equal to 6 sine 70 out of 8, which was equal to 0.7048. Okay, now still arc sine is going to be the same as that. Okay, we're going to have 180 minus x being given us arc sine of that 0.7048, which was also got to be 44.8 degrees. Now for us to get at x, we add to take it this side. Okay, but we add on both sides, then we subtract this on both sides. So that means we're going to have x equals to 180 degrees minus 44.8 degrees. Okay, we check out that. So we have 180 minus 44.8. Okay, one thing you need to know about these angles, some of them will be considered, some obtuse angles will be considered in case it fits, because the sum of all the angles here must be 180 degrees. The three angles must add up to 180 degrees. So in case only two angles we find that is now beyond 180 degrees, that means we will not consider that obtuse angles. Now let's check. If you add, now our answer is 135.2 degrees. Okay, that's our obtuse angle. Now if you add that 135.2 degrees to 44.8, do we have a chance of having another angle? Because remember, we have not yet got another angle here. 135.2, let's just put answer, plus 44.8. We have already 180. So that means, how comes this? That means literally this angle, there's no way we can get that angle to be what? There's no way we can get that angle to be 0. Besides, if you already add this to this angle, imagine our x is obtuse. We put that 135.2 here and we add to that 70. 135.2 plus 70. I think only two angles will already be beyond 180 degrees. Is 205.2. That means yet we have not even considered this angle. That's why we are going to leave out this. We neglect 135 degrees since can't hold. Okay, so we take x equals to 44.8. We take x 44.8 degrees. So we are considering only that. When it comes to those calculations of angles, you need to be very critical, because you may just mess up and fail to get the, and you leave out one, because sometimes for some cases obtuse angles are considered if it satisfies the condition of the angles of a triangle add up to 180 degrees only. So we need to be always careful when we are looking for angles. Another thing we're going to check on now, I think, is the next number. I think we should check for a number that can maybe have whereby we can include the obtuse. Find the angle x in the given. Let me say something like that. Put x there. Then here 3 centimeters. Here 4 centimeters. Here 38 degrees. Okay. And yeah, 38 degrees. So that here with this side we can, I think that's enough, because we have this side an angle, side an angle. Yeah, we can now try to get that x from sine rule. Still that same thing. Now here we have 4 out of sine x, 4 out of sine x equal to 3 out of sine 38 degrees. It's side out of sine of the angle opposite that side. Side out of sine of the angle opposite that side. You don't need to interchange them. So that here we will actually have sine x. If you make sine x a subject, you're going to have something like this: 4 sine 38 degrees out of 3. Okay. So that you're going to have something like your sine x going to be, if you this one, I think this one, if you calculate, let's see, sine 38. Okay, calculator is here. Sine of 38 is that, times 4 is that, then divide by 3. 0.8209 if you round off to 2 decimal places. 0.8209 if you round off to 2 decimal places. So now that means our x actually is going to be, now remember we have sine x equals to 0.8209. But how about now for case? Remember, don't forget this, remember sine x the same as sine 180 degrees minus x in case our x is obtuse. Okay, so we always consider acute and obtuse, which also implies that is equal to that. So for this first case, we're going let's name that 1 and name this 2. So for the case of 1, we're going to have x being given by arc sine of 0.8209. Okay, what would be our x? Shift sine of 0.8209. what would we have? 55.2. I round off to 1 dp. 55.2 degrees. Okay, now how about for the case of 2? In case when we think our x is obtuse, that means we are considering this other part now. So we have sine of 180 minus x giving us 0.8209. What does it mean? 180 minus x is actually equal to arc sine of that which we got to be 55.2 degrees here. So that means our x here will actually be now 100. If you take x this side, so you add on both sides and you must subtract this on both sides to remove. We are going to remain with 180 minus 55.2. So we have something like 180 minus 55.2. Okay, so it's 124.8. 124.8 degrees. Okay, so we have two values, that and that. You see, that's acute and this obtuse. Now we check for that. Let's check for this case. It's automatic that our acute is going to hold. Now we check for the case of obtuse. 124.8. We first add to that 38 degrees, and we see whether it's not going to. It's going to leave room for, since if we put obtuse here, that's 124.8. That answer, we just press answer plus 38. We're going to have 162.8. I think even if here is obtuse, we're going to still have 162.8 this plus that. That means we have room for this to add up to 180 degrees. That means that one can actually hold. So for this case, we are going to consider the obtuse angle as well. So we're going to have our x going to be that and that. So how do we draw that? Let me take it there. Okay, we have some space there. That means we are going to have a triangle of that kind. These are 38. Sorry, I had no space, but it's not 90. Then here is 3 centimeters. Then here was 4 centimeters. That. Then our x, the first x is this. Then another line will generate from this point up to that point for the obtuse one. That's this one. So you'd have another line from here up to there. Then you put there the angle, which is 124.8 degrees. So that means if here was a B, C, this time you're going to have something like A, B, C1 and C2 for the acute and the obtuse. That's how we'd have drawn that. Now let's go to the last number. The last number under the next example under the sine rule. We're going to have, we want to look at a case which has now which we can apply both cosine rule and sine rule. There are some triangles that you need to study whereby you can't solve using only cosine rule, or you can't solve with sine rule again. That's combining now what we looked at in our previous video together with what we will look at today. So let's say is number 4. Okay, find the side C and the angle A and B of the triangle below. Find side C, then angles A and B. Okay, let's draw the triangle, something like that. We've put here A, B, C. Then that means here is angle A, here is angle B, and here will be angle C, let's say which is 60 degrees. And now let's say we don't know this, which is C, and here that we have 6 centimeters and 7 centimeters here. When we have something like that, now first of all remember that if you try to use sine rule, we can get something, or we can if you see this angle and that, then we see that and this, but we will find that we have two unknowns, C and that, so sine rule will be hard even if you try to use this. But with cosine rule, we only need to know that two sides and one angle. We don't know that side, so that using cosine rule we can get that C very fast. So that's what we are going to do from cosine rule. we are going to have, remember, the one which is not forming the angle is always on the left side of the equal sign. Then the angles which give that the sides that form the angle is going to be their square, a sum of their squares minus twice their product, then times cos of the angle they form. That's a cosine rule. From cosine rule you see that. So that we have c squared is here 36 plus 49. That's going to be, say, 85 in total. 85 minus 2 times 6 times this 42 times that is going to be times 2 is going to be 84. So 84 times cos 60. Cos 60 is half. Actually, we're just going to have 42. That would cancel with that because cos 60 is half. We looked at that in our earlier video. So we're going to have that being for 43. Then root of 43, we have c is root of 43 centimeters. Better we leave in that form because it's a bit more exact. So we have got our c is distance, so we don't need to consider the positive, the negative side or sine of c. Distance can never be negative. So now we have got our c, that we can now use any, since we have the sides that and that, now we can use that and that to get angle A. But it's better we start with the smaller one, because there is that case of smaller one will always give a smaller angle. When you have this distance smaller, we will also give that smaller angle compared to this will give. That means our A will actually be somehow bigger, the bigger angle compared to B. So now let us check that, because this A we might find that it has to, since it's smaller, we might have acute, both acute and obtuse, because when it reaches angles we need to check for that. So let's say that from sine rule, let's start with a smaller angle, that's B, because this distance is smaller. So let's say that with 6 out of sine of that, 6 out of sine of B is going to be given by that out of the sine of that, so root of 43 out of sine of 60. So we can solve for B here. It implies that our sine B will be equal to root, 6 sine 60 out of root of 43. Okay, so that means actually the result there, what will we have? We're going to have something like let's check our calculator. We have 6 times sine 60, okay, that, then divided by root of 43. We have 0.7924. Let's just get the arc sine of that to get B now. Shift sign, answer 52.4 degrees. Now for this case, we also check for B if it can be having any other if it can be possibly be an obtuse angles as well. So now we have B. That means we also consider sine of 180 minus B, which will be the same as sine B, which will be the same as that. So arc sine of that, 6 sine 60, then divided by root 43. Arc sine of that was that 54 point that. Then that means now we're going to have 180 minus 54 point that, 180 minus answer from what we did before. First, because we already did that, so it's 127. If you check here, we're going to have here B going to be 127.5 degrees. Now if you add that 127 plus this 60 plus 60, we're going to have 170, 187, which is already beyond, just beyond this without even A. It's already beyond 180. That means B, we can't consider the obtuse one, we only take the acute. Okay, now we go for angle A. Still from sine rule. Okay, we are going to have now, we have now A, so we can consider that 7 out of sine A, 7 out of sine A equals to, now let me say 6 out of sine B, or even root, let's take that and root 43 out of sine 60. Okay, so as sine A is going to be 7 sine 60 divided by root 43 if you make sine A the subject there. So it's going to be, that means actually A is going to be, if you get arc sine of that, it's 7 times sine 60. It's going to be that, divide by root of 43. 0 point that, then arc sine of the answer to get that 67.6 to 1 decimal place. So we have 67.6. Now we check for the case of the obtuse. Remember, for the obtuse one of that, remember we have 180 minus A, giving that the same as sine A. So now that means it's going to be 180. For us to get A here, it's going to be, because this is equal to that, so it's going to be 180 minus that. We already done that. You can go back to the video to understand more. You do some work also. We have that 112.4 degrees. Now we check 112.4 plus 60. We have only 172. It doesn't exceed 180. So that means actually we have that the obtuse angle of A exists. So how do we draw for A? Let us, I think we can use this other small space here. Okay. A, B, C. This one was already 52.4. We don't stress there. Here with C was already given 60. Then A, we have the first one, which is the acute 67.6. Okay. Then another one from this point to that line, 112.4 degrees. Then we have here outside root 43, which is C. Here we have 6 centimeters, 7 centimeters. So guys, welcome back to well done, and thank you for watching my channel. Please, I welcome you back again next time in my next video. Please don't forget to like, subscribe and share for more videos. Thank you.